Welcome to surface area of a pyramid. So now we're going to be finding the surface area of pyramids. All right, so pyramids, just a little review of pyramids. Pyramids are three-dimensional closed surfaces. The one base of the pyramid is a polygon, and the lateral faces are always triangles with a common vertex. So remember, triangles, our sides are triangles. So now we're going to have a little bit different formula for our surface area because our sides aren't rectangles anymore, they're triangles. So the vertex of a pyramid, the point or apex, is not in the same plane as the base. Right? So the lateral sides all meet together at one point. Pyramids are also called polyhedra since their faces are polygons. The most common pyramids are regular pyramids. A regular pyramid has a regular polygon for a base, and its height meets the base at its center. The slant height is the height or altitude of each lateral face. Right? So we're not dealing with the inside measures anymore. So now when we find a surface area, our height is not going to be inside the figure, it's going to be outside the figure, and it's going to be the slant height. I can show you with the two-dimensional models, but I'll be able to show you with three-dimensional models in class, just to make sure that's clear to you. But if just to think about, the sides of the pyramid, we're on the outside, the side that slants, not the inside. So here are some differences between prisms and pyramids. Right? So pyramids have one base, prisms have two bases. So now think of our surface area formula for a prism. Right? We had 2b because there were two bases. What do you think we're going to have for a pyramid if there's only one base? A prism does take up more space than a pyramid, right? Because the slides slant in. Pyramids, so maybe that's going to affect our surface area. Pyramids have a vertex opposite the base. Pyramids have a slant. They have lateral faces that are triangles. Prisms have lateral faces that are rectangles. Right, so let's take a look at this formula. Let's take a look at some pyramids, and then let's take a look at the formula. So pyramids are named for the shape of their base. So here we have a triangular pyramid. The base is a triangle. We have a square pyramid, a pentagonal pyramid, a rectangular pyramid. So a square pyramid is a type of rectangular pyramid. Hexagonal pyramid, heptagonal pyramid, decagonal pyramid. So the decagonal pyramid, the base has 10 sides. And the heptagonal pyramid, the base has 7 sides. And hexagonal, base has 6 sides. Pentagonal, base has 5 sides. So regardless though of what shape the base is, the sides are always triangles. So surface area, remember, is the sum of all the sides. So here I've kind of cut my, my pyramid. Right? So we have one base. A square pyramid has a square base and 4 triangular faces. We also will look at a triangular pyramid. We're not going to be finding the surface area of the other pyramids, maybe a rectangular pyramid. So square, rectangular, and triangular. The triangular faces are all isosceles triangles if it's a right pyramid. And we're only going to be dealing with right pyramids. The height of each triangular face is the slant height of the pyramid, right? If it is a regular pyramid. And we're only going to be dealing with regular pyramids and right pyramids, no oblique pyramids. Right? So notice we only have one base. Right? So instead of having 2 bases to calculate, just one base. And we have sides that are rectangles. Sides that are triangles. Right? So we're still going to need the perimeter. If we take the perimeter of our base, notice that we'll have the bases of all of those triangles all together. Right? And now our height is going to be the slant height because it's on the outside. So we're going to take the slant height to find the height of all those pyramids, the area of all of those triangles. But these are triangles. Remember the formula for the area of a triangle? It's half base times height. So instead of taking the perimeter times the height, like we do in prisms, we're going to take half the perimeter because they're triangles, not rectangles, and the formula for the area of a triangle is half. Right? So 1/2 is because the sides are triangles. Over in the right it has that listed. I could probably star that for you. Now sometime that star will come up. And instead of using the height, we're going to use the slant height. Sometimes that's abbreviated as an S, and sometimes it's an L. I like to use L. Although sometimes I'll switch between. I'll have to switch between L and S. The only problem with the S is then it looks like surface area. So the one having one S be surface area and another S be slant kind of is confusing. So either we can call it area is base plus 1/2 perimeter and S for slant, or S is base plus 1/2 perimeter times L slant. But either way, L that means slant. Right? So the differences between the prism and the pyramid is that we only have one base, so we can drop that 2. And because the sides are triangles, we're going to use 1/2 the perimeter, and we're not going to use the height, we're going to use the slant height. That's it. That's the only differences. All right, so let us continue on with our pyramid. All right, so we're going to work a little bit with finding the slant height, because sometimes there's only one height in a pyramid, in a prism, right? There's not 2 different kinds of heights, there's just height. But a pyramid has 2 kinds of heights. It has slant height, the height for the triangles on the outside, and height, the height on the inside if we were finding volume. So because there's 2 different heights, sometimes we're not given slant height, sometimes we're given height for volume. So we're just going to practice finding slant height, okay? Or finding any measurement we might be missing. All right, so notice we have a triangle there. It's a right triangle. And if this is a square base, one side is going to be half the base. One side of the triangle is going to be the height. And one side is going to be the slant height. Right? And that's how we're going to find that. You have a diagram somewhat like this right next to finding the surface area of a regular pyramid in your notes. Just add in that side, that line there, and then put in half a side. So just put in what I've written in my handwriting, okay? Just put it on that picture there. We've got, put side on one of the sides, and then complete that triangle there and put half a side, okay? So that you have that visual to help you when you're trying to find a missing measure in the pyramid. Now we're going to ask what we're going to practice. Right? You have 1 in your notes. I have many more. And this is the one you have in your notes. Right? So if we don't know the slant height, the height, or the base, we'll use Pythagorean theorem to find it. So here I don't know the base. I know the height and I know the slant height. But because we have a right triangle here, actually let me write in a nice color here. There we go. Because we have a right triangle here, we can use Pythagorean theorem, right? So this blue side here is half of x. We're looking for x because we don't really care that much about what the distance is from the center to the edge, except we need that to find the length of the whole side. I don't want to put a half of x in there because I don't want a half. Let's just call it y, okay? But we know that y equals 1/2 x. Right? I just want to use a single variable. I don't want to use half. All right, so now we're going to solve for y, and then we'll just double it to get x. That would be the easiest thing to do, rather than solve for half of x and then use half of x in this equation in Pythagorean theorem and then solve for x. It'd just be a lot easier not to have a half in there. Okay, so now let's set this up. And we're going to use Pythagorean theorem. Ooh. Sometimes when I'm writing, I can't stop. Otherwise, when I start writing again, sometimes the letters are not where I want them to be. So we're going to use Pythagorean theorem. So that would be y. So it will be, let me write it in words, and you write it in words. So it's going to be half the side squared plus height squared equals slant squared. Okay, that's always going to be the formula. All right, and I'm going to take, so I'm going to use y for half the side. So I just wanted a single variable. So y squared plus our height is 12. 12 squared equals 13 squared. And now we'll just solve. Y squared plus 144 equals 169. Subtract 144 from both sides. Y squared equals 25. Take the positive square root only, because measurement is positive, and y equals 5. So if y is 5, remember, y is half of x. So 5 equals half of x. If I multiply by 2, 10 is what x is. Okay? So now we found the value of x. Okay? And now that we know what x is, we could actually find the surface area. Since there's a lot of space, I'll be going over surface area, specifically in the next podcast. Let's just find the surface area, because you have enough space, I think, in your notes, because it doesn't take up that much space. So let's just find the surface area of this one. Right? And then the rest of this lesson, we're just going to be looking at finding a missing measure using Pythagorean theorem. And then the following podcast, we're looking at finding our surface area. Well, sometimes we'll have to use Pythagorean theorem to find our missing measure. All right, so let's solve here. So we'll have a number of formulas. So surface area is our base area plus 1/2 the perimeter times the slant. So our base area, this is a square. Okay, so this is a square pyramid. Okay, so our base area is going to be 10 squared, or 100 units squared. And then our perimeter, right, it's a square. All the sides are exactly the same. So the perimeter is going to be, well, you can write it as 10 plus 10 plus 10 plus 10, or 4 times 10, right, because they are all exactly the same. So our perimeter is 40, and then here's our slant, 13. All right, so then our surface area is going to be the area of our base, which is 100, plus 1/2 times 40 times 13. See, it's not going to take up that much space. So surface area is 100 plus half of 40 is 20. 2 times 13 would be 26. So 20 times 13 is going to be 260. And so our surface area is 360 units squared. And that's our surface area. All right, so we're going to look a little bit more at Pythagorean theorem, and then we'll find some more surface area. And I'm kind of wondering now, did I have this as a problem later on in the notes? I don't think so. Well, if we did, we've already done it. All right, so let's continue on, and let's find some missing measures. All right, so we want to find the value of x. The base area of our right square pyramid is 64 units squared. All right, so remember what we just solved for the area of a square on the last page. So the area of a square is equal to s squared, right? So if 64 is the area, and that's equal to s squared, if we take the positive square root, we'll get the length of one side, right? So square root of s squared is s, and the square root, the positive square root, ooh, my s looks like a 5. Now I lost the bottom half of this s. I wonder if it ended up in the right spot. No, not even close. All right, well, we'll just, can we move that? No, we can move everything else other than that. Can I? There we go. Yeah, let's fix that x, because it looks weird. I don't know how I brought that up. Didn't touch anything. Just comes up. All right, so now we have 8. All that work just to get an 8. And now, can I move this up a little? My writing is right over, there we go. All right, so the whole side length here is 8. Remember, this is half, right? This is half a side. Right, so that means that length there is 4. So now let's set this up to find our x here. So we're going to use Pythagorean theorem. I'm just going to abbreviate. All right, so we have, remember, it's the half side squared, so that's 4 squared, plus our height squared. I'm not going to write the formula again, but I will write what each of these things are. There we go. So that would be plus 8 squared equals x squared. All right, now we'll just simplify. All right, so we have 16 plus 64 equals x squared. That would be 80 equals x squared. Not a perfect square, but we'll simplify. Good practice for us. All right, so x is equal to, and actually let me just put that over here. All right, so 8 and 10 divide evenly. Boy, this, or before, actually when I finish this podcast, I'm going to reorient the board. It was fine earlier, and that 4 is 2 and 2. As you can see, not so much. There we go. All right, so I wonder if I'm going to, no. Okay, so it goes too far to the left. I'll have to write further to the right. Come on, move over. All right, circle that one. Circle 1, 2, cross off the other 1, 2. Circle 1, 2. Let's see if I put it right here. Pretty good. Cross off the other. And the 5 is left. I'm figuring out the board. Just move a little further to the right. All right, so 2 2's come out. So 2 times 2 comes out. That's 4. And 5 stays in the radical. We need exact answers. No decimals here, otherwise you're going to have rounding error. All right, so just simplify your radicals. And most of the time you'll actually have pretty numbers, integers. All right, but if not, we're trying to make sure that there it goes. That was weird. So I'm watching the screen recording, and it didn't move for like 4 seconds, and all of a sudden it jumped 4. Okay, so let's look at this one. All right, so very similar problem, except it's even easier here. We don't even have to solve for the side. All right, so this is going to be equal to half a side. So if the whole side is 16, half a side, did I put an 18 in there? Nope. And this is our slant. So actually the board is not too bad on the left side, it's just the right side. And again, we're going to use Pythagorean theorem. I should try to write to the on the right, left-hand side as much as possible, I guess. So 8 squared plus 6 squared equals x squared. 8 squared is 64 plus 36 equals x squared. That adds up to 100, and this is a perfect square. We'll just take the positive square root of 100, which is 10. And so that's our slant height. Now, and we would use slant height for finding the surface area. Okay, let's look at the next one. There's like 6 of these, maybe 6 or 7. Even though we're going to need slant height, not height, it's good to practice. Where's my line? Let's see how long it takes to come. 1, 2, 3. Is it coming? 4, 5. Yeah. Got the H-E-I-G part of an H and slant. All right, and this half a side here, the whole side is 12. Half a side is 6. So I didn't, because I picked up the eraser. Oh, I guess I could just leave the 6 there. Well, there it goes. All right, so actually I'll write anyway, use Pythagorean theorem. All right, so we have, come here, reading. All right, I'll just start writing 6 squared plus x squared equals 11 squared, and that'll pop up in a second. So 6 squared is going to be 36, except I don't know where to write, because I don't know where the words are going to pop up. Use Pythag T theorem. There it is. All right, so 36 plus x squared equals 121. We're going to subtract 36 from both sides. So x squared is equal to, come on, and it's going to be 585. Yep, and that is not a perfect square, obviously. Can I fix that 8? It's a huge gap there. Yeah, the 5, I can move the 5 over. Yeah, no, easier said than done. I'll get that to stay. What about the 5? Move the 5. There we go. All right, so now we'll take the square root. And the square root of 85, but only the positive. All right, so what does 85 break down to? Maybe if I write over here. It's divisible by 5, and that would go in 17 times. Well, those are both prime numbers, and they don't match. So x is the square root of 85, and we are done. As soon as my 85 comes up, we'll be done. Come on. We're all waiting for you. Any day now. Okay, well, maybe x will be just an empty radical there. Just imagine there's an 85 there. And I'm going to change the page, which will occur first. That 85 or the page changing. Now I'm curious. Did it ever pop in? Nope. It's kind of bothering me. There we go. I guess it wasn't going to. We should have gave up a while ago. All right, so here we want to find the value of our variable. Our area of our base is 36 units squared. So we know that if remember the area is side squared, so 36 is our side squared. Take the square root of both sides, and 6 is the length of the side. This is going to be half a side, so that's 3. Right, and so let's move that a little bit. There we go. That does what I told it to do. All right, so now we use Pythagorean theorem to find the slant. This is our height. This is the slant. All right, so we have 3 squared, the half a side squared, plus the height squared, 6 squared, equals our slant squared. So that would be 9 plus 36 equals x squared, which is 45. Take a square root of both sides. Only going to take the positive. Now 45, not a perfect square. I'm going to write over here, I think, so I don't have to deal with the right side of the board. All right, divisible by 9 and 5. 9 is perfect square. 3 and 3, so 1 3 comes out, 1 3 goes away. So simplify, this is going to be 3 square roots of 5. The 5 stays under the radical. And there we go. That one's done. I don't think there's too many more of these. Like I said, not too many more of these. We're done. So we'll solve this problem and many more like it in the next podcast. Bye for now.